Thank you, Nicole. I'm assuming the mic is working because I can hear it echoing, so. Titan, liquid lakes, chemical inventory, and the search for life outside of Earth. My name is Ishaan. I'm a biochemistry major, minoring in physics, and I've been working as a researcher for NASA's Dragonfly mission for the past 2 years or so. Dragonfly is one of the most sophisticated missions to ever be planned and is going to Saturn's largest moon, Titan, in the next decade. I'll talk more about that later today, but Titan's a very fascinating ocean world. Show of hands, has anyone ever heard of ocean worlds before, know what it is, somewhat of an idea? Oh, wow, few people. Very nice. Let's address a little bit more about that first. Ocean worlds are celestial bodies or places that have a substantial amount of liquid present, whether that be on their surface or underneath their surface. And this can be either liquid water or other liquid like magma. The planet Jupiter has 4 ocean worlds that it hosts. Jupiter also has a ton of other moons, but these are the 4 ocean worlds that it hosts, starting with Io, which has liquid magma underneath its surface, followed by Europa, Ganymede, and Callisto. Jupiter's neighbor, Saturn over here, also hosts 2 icy satellites, which are Enceladus and Titan. Titan we'll talk more about. And then far off in the solar system, we have Neptune's ocean world, Triton. These ocean worlds are very interesting places because they host the 3 key ingredients for life that first give rise to life on Earth. The first ingredient, as you might guess, is liquid water. But on a broader scale, it's actually a universal liquid solvent, something stable that can remain as a liquid and allow for things to mix in. On Earth, this is water. And just to look at on a microscopic level what it looks like, it consists of 2 hydrogen atoms, 1 oxygen atom that come together to share these little circles called electrons to form this Mickey Mouse structure over here. This is also why water is referred to as H2O. Water is pretty essential on Earth, makes up cellular structures, and is a pretty essential aspect for life. The second ingredient that's necessary for life as we know it is a chemical inventory of 6 of the most essential elements. These are dubbed in an acronym called SNOPs. Scientists are very corny, I know. But it does make it a lot easier to remember what these elements are. These are carbon, hydrogen, nitrogen, oxygen, and phosphorus and sulfur. The combination of these 6 elements make up a lot of key things that are essential for life. Just like how we saw in the last slide, 2 hydrogen atoms and an oxygen atom come together to form water. But other combinations can form things like fats, proteins, carbohydrates, even our DNA, things that are pretty essential for life. The third key ingredient for life that's necessary is a sustainable energy source. On Earth, we have external energy sources like the sun. We see it every single day. However, there's one internal energy source that kind of goes unnoticed from time to time, and those are hydrothermal vents. This is what it looks like underneath an ocean on the seabed. And I know this left image looks kind of complex, so let's talk a little bit more about this. One of the main reasons I included this was just to show that hydrothermal vents are actually a result of internal heat driven from underneath the Earth's surface, which creates an environment that can produce all these chemicals that can be incorporated by life. An energy source is important because it can drive those certain chemical reactions that can produce those compounds that are really essential for our life. Now that we know what the 3 key ingredients for life are, how they give rise to life on Earth, let's talk about why Titan is so interesting. Titan is the only other place in our solar system that actually has a dense atmosphere that is pretty similar to the early Earth's. It is also the only other place in our solar system that actually has liquid lakes on its surface. It's important to note, though, these lakes are actually not made of water. It's kind of too cold on Titan for that. It's about negative 290 degrees Fahrenheit, and that can be kind of hard to imagine or understand because we don't see those temperatures here on Earth as much. But just to put it into perspective, water actually acts as a rock on Titan. It's so cold that it denses up and is basically in the form of a rock. Just like Earth has water comprising the lakes, forming clouds, raining, precipitating down, liquid methane plays the exact same role on Titan's surface, comprising it lakes, forming clouds, and then raining. So Titan has the first requirement of life, a liquid solvent present on its surface. It also has a complex chemical inventory in its atmosphere and on its surface. Let's take a look at this picture, which, again, looks pretty complex. So let's break this one down. Starting at the top here, there's energetic particles from either the sun's UV photons or other energetic particles in outer space that come into contact with the atmospheric particles. You all remember one of the other ingredients, right? The sustainable energy source. I guess Titan has that too. So the energy sources dissipate some of the molecules that are there, cascading down into a chain of reactions that produces complex organics. Some of these organics have been measured and are actually known to be incorporated into life here on Earth. Some of these end up staying in the atmosphere, forming the organic haze, and some of them end up precipitating down to the surface, where they can interact with the liquid methane oceans that are there, and they can even slip through the cracks and go into interact in the liquid water ocean that's present underneath Titan's surface. It's interesting that these chemical molecules can enter different terrains where they can further create more chemical reactions that can produce things called biosignatures. I know, scientists have so many fancy words. Biosignatures, to break it down though, are basically any substance or phenomenon that either indicates evidence of past life or evidence of current life. These are things like complex chemistry, minerals, organic matter, or microscopic fossil structures. Now we know what ocean worlds are, what key ingredients there are for life, and what biosignatures are. How does that really tie together? The Dragonfly mission. Dragonfly is a rotorcraft that's planned to go to Saturn's largest moon, Titan, in the next decade. It's supposed to launch in 2027, but it won't get there until 2034. And two of the main scientific goals, or let's start with the first one. One of the main scientific goals of Dragonfly is to look for compounds and potential processes that are responsible for the creation of biologically relevant compounds. So these would be things like the 6 essential elements that we saw earlier and the things that are made up by those 6 essential elements. Another scientific goal of Titan is to actually try to find biosignatures, so things that indicate either the presence of past life or the present life. This is a picture of Titan's surface that was taken by the Huygens probe back in the early 2000s. And Dragonfly is one of the most sophisticated missions to be planned, as I was saying, because it's going to fly around to the different surface features that Titan has to offer and hopefully improve our understanding of what the surface is, what the subsurface, meaning underneath the surface is, and what the chemistry really looks like. Like I said, I've been working with this mission for the past 2 years, and I just love sharing this with other people, hence the WheaTalk. Some key takeaways from what I talked about. Ocean worlds are fascinating places because they can give rise to and sustain life as we know it and as we don't know it, because they host the 3 potential key elements, which are a universal liquid solvent, chemical inventory, and a sustainable energy source. Titan exceeds all of these requirements, and Dragonfly is going to help us assess more about that when it goes to its surface. With that said, I conclude my talk for today, and I'd be happy to answer any questions at the reception that's going to take place after all the WheaTalks in Diana Davis Spencer Cafe. Thank you. Thank you.